Hey guys, what's up? Welcome back to another paper. So here we'll be doing a complete walkthrough of the AS maths paper. So even for you A2 guys or full A-level guys, you can use this paper. And this is the second paper, which consists of the stats and mechanics only. And yeah, this is really short, hour 15, and there's thankfully only 9 questions to do. So where does it say 9? It says 9 here, so there are 9 questions. But yeah, I'm gonna go break through every question and hopefully clear out any single doubts and explain certain concepts as well. But yeah, without further ado, let's go. So let's start with section A, statistics. Yeah, so there are 5 questions here. So number 1, so Sarah is investigating the variation in daily maximum gust T in kilo N. I'm not sure what the N unit stands for. You guys can leave me a comment for that. For Camborne in June and July 1987. So she used the large data set to select a sample of size 20 from the June and July data. So this could refer to, it's not quite specific here, but I'm probably assuming days because we're talking about the daily maximum gust. So let's assume there are up to 61 days because June has 30 and July is 31. Okay, so Sarah selected the first value using a random number from 1 to 4 and then selected every third value after that. And yep, and so this is basically in regular intervals. What this means is that if you're supposed to select a value of 1 to 4, like for example 3, and then every third value, so if it was going up in sequential order, such as 1, 2, 3, 4, and then 5, 6, 7, all the way up to the last day, say 61st day, then the third value would be going up in the next 3. So adding 3 more, if it was 3, the next one would be 6, and then 9, and then 12, and so on. And this should give us a list of say 20 values or 19 or 20 values. Now that's what it means here. Well, that's what I believe it means. So state the sampling technique Sarah used. So this one is 100% systematic. Something that is systematic means that you want to put the data set in a correct order. You would pick values in fixed regular intervals like they did here. For example, every third value. This is a form of systematic. So it's always regular intervals. Okay, that's it. So B, from knowledge of the large data set, explain why this process may not generate a sample of size 20. Well, if we consider these June and July dates for every single day, as I said, there's 61 days. Let's just make it simple, assume there's 60 days. If we're taking every third value, so in other words, we're going up in 3s, let's just divide 60 by 3 for a second. And here we realize we're going to get exactly, roughly, or give or take 20. Now, this is only true if every single day has been accounted for. So we're not missing any single dates. If for some reason we're missing some days in June and some days in July, there's a high probability that you will not get a sample size of 20 because you're going to be skipping days. And if you're skipping days, it's no longer systematic. And this would be a problem. So this would be the answer. Your answer could be that some days may not have been included. So days in June or July have been excluded or was not recorded in the large data set. That's really what they're looking for here. Okay, now let's move on to the next bit. So the data Sarah collected are summarized as follows. So the sample size is 20. The sum of the t values, the daily maximum gust, is 374, and the sum of the gust squared is 7,600. Now calculate standard deviation. So what I did here is very straightforward. The standard deviation formula is basically the square of the variance. And the variance is the sum of t squared over the sample size minus the mean squared. And the mean is the sum of t over n. I just calculate each one and plugged it in as I went along. This is how I always do it. And personally, I find this easier. If you're not sure how to memorize this one, I would do the mean first and realize that the variance is very similar, except that t is t squared. And then you minus the mean squared. And then to get standard deviation, you just square root your answer. And that's it. That's really it. There's not much I can say here, but other than that, I'll show you guys in the next question. So just want to say one thing. If you guys are enjoying this video, give me a like and subscribe and share to your mates. Anyway, here we go. Number 2. So the partially complete histogram and partially complete table show the time to the nearest minute that a random sample of motorists was delayed by roadwork on the stretch of motorway. Now, one thing you have to note here as well, when they use the term nearest minute, this means that they've already rounded the figure. And this is very important histogram because for histogram, like you see below and the graph as well, there should be no gaps. And if you look at the table, the graph clearly, you can see that for 4 to 6, for some reason they didn't do 4 to 6, they went down to 3.5. And that's how it is. When you round to the nearest minute, it's always plus minus 0.5 on each side. So for each one, we need to update. So 4 to 6 would be 3.5 to 6.5. 7 to 8 would be 6.5 to 8.5. Now histograms, you can't have a single point, because then that would just be a straight line which has no weight. In fact, 9 would be, again, plus minus 0.5, so it would be 8.5 to 9.5, and so on. 10 is 9.5 to 12.5. So keep on doing this until you guys get figures like this. I always recommend that you lot do this, yeah? So 15.5, oops. So this is pretty much the main part of histogram. It's always get the figures correct, especially the widths. So there you go. So it's between 3.5 and 20.5 now. Now this is going to be your class width here. So let's just get the figures ready. Class width, number of motors. So this is of course our frequency. So let's call this one F or freak. Freak. Now just to understand histograms, and before we complete this, I think it's best we complete this table first and complete the chart. Now, and you'll notice that on the y-axis there is no values given except 0, so we don't know the actual height, but it's very easy to calculate the height. For any frequency density, always draw this kind of nice little graph. Just put this nice block and treat this like a rectangle. Let's say that the area is called the frequency, yep, which it is. That means the width is the class width, which is the width, and the height is the frequency density. So these are 3 units. So we can say frequency equals frequency density times a class width, just like base times height equals area. Now looking at each one, we have some frequencies. We know that between 3.5 and 6.5, the area is 6, which is this region here. For between, what's this one? 12.5 to 15.5, which is this column here, we have the area which is 9. And I think that's all we're given. Yeah, that's what we're given. So what can we do with this information? Well, since you know that the area is given, we can therefore find the height. So if we know that the area is 6 and we know that the class width, so we got a width of 2, we have a width here of 3, because between 3.5 and 6.5 the width is 3. So 3 times something is a 6. Well, we know it's going to be 2. So we can kind of see that every block is going up in 1. So this area, this height here is going to be 2, 4, 6, 7. I hope it's 7. 2, 4, yep. This one has a height of 3. So I'll put 3 in the top. This one has a height of 1. So let me just put the numbers at the top here. That's it. So if we have the height, well, we can find the area. So this height is 7 and the width here is clearly 2. So 2 times 7 is 14. This one has a width of, what's this? 5. So 5 times 1 is 5. And I think we're done. So we just fill it up. So the last column is 5, so put 5 over here. This one here we found is 14, so put over here, and we're done. Now all we need to do is, what do we need to do? We just have to draw the histogram for 8.5 to 12.5. So we know 8.5 to, okay, we got 2, we got 8.5 to 9.5, the area is 17. So this has a unit of 1, but a height of 17. So if the width is 1, so let's say up to here, that means 1 times 17 will give us 17. So we have to go all the way up to 17. So let's see, 7, 8, 9, 10, 12, 14, 16, 17. So it'll be 17. So it'll be between here to here. So this will give us a complete, oops. So yeah, use a ruler, yeah. This will give us a complete height of 17. Next time I think I'm just going to complete this one in advance and just explain to you guys. I think that's a lot easier. So this would be our 17 area. We can see that 1 times 17 is 17. Now for the last bit, let's have a look. Between 9.5 to 12.5, which is this column here, we know we have a class width of 3, so that the class width is 3, and the area is 45. So 3 times something 45, well, it'll be 15. So the frequency density, I should have put it here. So 3 times 15 will give us 45. So we need a height of 15. So the width is 3, we check, so it's from here to here, and a height of 15, which is about here. So let me label this 15, and this was 17. And that's it, guys. I think this is done. So just draw your shape and then just label it. That's it. All done. So let me just put the heights there. 17, 15, area is 17, area 45. Yep, that's really done. Now, what was the question? So estimate the percentage of these motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes. So essentially that's from here, 8.5, so that covers it. So it'd be 17 plus up to 13.5 plus this as well. So 13.5 lies between 12.5 and 15.5. So if we look at 12.5, 15.5, we can just split it 13.5 to be here. So this would be the limit. So if the whole area is 9 and if the width was 3, the width is now going to be 1. So 1 times 3 will give us 3. And this of course be 6. Another way you can look at this is that this is just 1/3 of the area. So we've got 3, so we just take 3 from here. So 1/3 of this will be 3. So it'd be 17 plus 45 plus 3. And that gives us 2065. So this means that the percentage of motorists who were delayed by the roadworks for between 8.5 and 13.5 minutes was 65 over the total number of motorists, which I already calculated was 96. So it will be 65 over 96. And if you put that in the calculator, you should get about 67.7%. That's it, all done. So yeah, let's move on to number 3. So if you guys are enjoying this series so far, again, give me a like and subscribe and share with your friends. Now here we go, number 3. So this one's gonna be super easy. So the Venn diagram shows the probabilities for students at college taking part in various sports. Okay. Now A represents the event that a student takes part in athletics, T here represents tennis, and C represents cricket. And then they gave us a couple unknowns, which were P and Q. So one thing to know about Venn diagrams, everything inside the Venn, including the inside the circles and outside the circles, must total up to 1 or 100%. So it seems okay. Now, the probability that a student selected at random takes part in athletics or tennis, in other words, in the areas of A or T, equals 75%. So before we look at the questions, we know that everything inside here is 75%. So this means Q plus P plus 0.40 equals 75%. So let's just put all of these out here. This means that the outside these circles, this will give us a remainder, which will be 25%, because 25 and 75 give us a whole. So this means these two, 5 and P, must add up to make 25%. So this means we've already got 5% on here. This P value must be 20%. So P is automatically 0.20. So this means this P value is also 0.20. And if we know that all of this is 0.75, doing some quick maths, this gives us 60. This means that we must need 15 more. And yeah, it looks like we found P and Q. So find the probability of the value of P. Well, we knew is 0.20. Now state, given a reason, whether or not the events A or T are statistically independent. So statistically independent literally means if the probability of A times the probability of T equals the intersection between A and T. So we need to prove that by doing the probability A, which is 0.35, and the probability of T as a whole, which is 60 by the way. When you multiply them, we need to check if it gives us an answer of 0.20. So I did it over here. I can show you my diagram. So this is the result of the Venn. It looks a bit like this. So updating all the values and making it look nice. And this is the assumption. We need to prove that A times T gives us A and T. Well, looking at the left hand side, 0.A, which is 15 and 20, gives us 35. And T, which is 20 and 40, gives us 60. Multiplying them together will give us 0.21. So no, they're not independent, because 21 of course isn't 20. And that's it, that's what you say. 3 marks for that. And lastly guys, I know I'm doing this super fast. For part C, we need to find the probability that a student selected at random does not take part in athletics or cricket. So a student does not take part in athletics or cricket. So we're looking at someone that isn't part of the A circle, nor is part of C, meaning you're left with 40 and 5, meaning the answer is 45. That's it. And yeah guys, thanks for watching, and I hope these videos have been helping so far. Give me a like if you're enjoying this, and otherwise I shall see you in a bit. Ciao.